A lever is 6.1 meters long. The distance from the fulcrum to the weight to be lifted is 1 meter. If a worker pushes on the opposite end with 440 newtons, what is the maximum weight that can be lifted? Okay, so we are looking for a maximum weight, and we see fulcrums and yeah, basically a lever and a fulcrum. So we're working with torque. We're actually going back a unit. What we're trying to find here is some amount that equals a certain other amount, and this is involving torque. So since these amounts are going to be equal, we're looking at a problem involving rotational equilibrium. And rotational equilibrium is when the sum of torques, again this is sigma, capital sigma to signify sum, the sum of torques equals, equals 0. Actually, I'll go ahead and draw a sandwich. This is kind of like a Newton's law sandwich, except it's with torque, not with forces. So we're actually just going to have two torques, and I'll show you why in a second. But just to set up the equation, I'll draw them here. This T1 and T1 minus T2 equals 0, which means T1 equals T2, which is what we want. Okay, so this is actually part 2 of our 5-step process. Part 1, I'm actually just going to draw a diagram for. Let's go ahead and do that. Okay, let's use a line tool. Okay, so you have a lever, and it's 6.1 meters long. So this is 6.1 meters. And there's a fulcrum. So, and 1 meter from this, from the end to the fulcrum is where the weight is, right? So then you have a weight here. And on the other hand, or end, or lever, whatever you want to call it, you have a force. So I'll actually draw this like that. It's not great, but it's what we need. 5.1. And we see this, so that's 5.1, that's 1. That's really all we need. And we see, oh, and I'll add another formula here, but I'll add that in a second. So we have the fact here that the worker has pushed on this end at 440 newtons. And I found this amount by 6.1 minus 1, if you didn't realize. Yeah, so 440 newtons. So, and let's say this weight has, well, let's call it, what should we call it? Capital W. How about that? Okay, so we're looking for W. We're looking for the maximum weight. And we're given that, but how does it all connect? What is this? Well, that's torque, right? So what is the equation for torque? Let's think back. Now, if you remember, torque is a perpendicular force times its radius. So you'd have, let's say, a lever and a force perpendicular. You'd take the radius, you'd multiply it by the force, and you get a torque. And that's how it works. So you could say the radius is perpendicular, or the force is that. I don't really. It's just the concept that matters. So let's move on to step 3 because we have the formulas and we're going to work this out. Oh, and let's say this is torque 1. And, well, that's not torque 1, that's a force for torque 1. So let's say that right there is torque 1. If there's a difference between the two, this is the force and this is the torque of the force. And then this is torque 2. This torque 2, let's torque 2. Okay, that's good enough. Okay, so that's torque 2. And they're equal to each other. So what is torque 1 then? Well, let's look at the radius. The radius is 5.1, right? Because you have the fulcrum. The radius is measured from the center of the fulcrum to the actual place of the force. So 6.1 minus 1 is 5.1. And the reason we know that, we just deduced that it's 5.1 meters because this is 1 meter. So since that's 1 meter, the force is being applied on the opposite side, so opposite that. Yeah. So 5.1 times 440 newtons, and you'd get I think 2,244. Yes, that's what you get. So this torque equals 2,244 Newton meters. And the reason it's Newton meters is because a force times a radius. Well, the force is in newtons, the radius is in meters, so Newton meters. It just makes sense. Let's see. So now, okay, we're going into really complicated math here. Okay, so are you guys ready for this? Okay, you have the second torque, and it's got this weight. So the force would be the weight, right? Because the force of gravity is weight, right? Times, oh, what's the number we have here? 1. Oh no, okay. So 1, so we get its weight, and your units are Newton meters. Wow, okay. I'm glad we got that out of the way. Okay, so torque 1 equals torque 2. That means 2,244 equals W, and this is Newton meters. Okay, let's just... And really we are done here, but I just want to point something out real fast. Weight, Newton meters, right? So you have this. This isn't in newtons, this is in Newton meters. So you'd really, if you cared, divide both sides by 1 meter, right? 1 meter. But you really, I mean, it's important, but nobody really cares. So yeah. Your final answer is the maximum weight this guy can push or raise, I guess, would be 2,244 newtons, which is like a lot, I guess. I don't know. And step 5. So what was my... Oh, I used the very basic explanation. I said it's reasonable given the data. It's, there wasn't much to explain, but yep, that is FRQ 12.